This is an MQ-9 Reaper drone, easily distinguished from other aircraft by its opaque canopy. That's because the pilot sits here, even as this Reaper flies over the high plains of New Mexico. This portable container is called a Ground Control Station, or GCS, which can be up to 1,600 miles away from the drone. That's about the distance from New York City to Puerto Rico. Over the last 2 decades, the Reaper has completely changed the state of modern warfare.
The value that the MQ-9 provides is really unmatched with modern aircraft.
In 2020, a Reaper strike killed the Iranian general Qasem Soleimani, but the Reaper's perceived effectiveness on the battlefield may have been overshadowed by the controversy it's caused. The biggest concern: civilian casualties.
While the U.S. military today acknowledged that a drone strike in Kabul they initially said killed an ISIS suicide bomber, in fact killed only civilians.
In 2021, as U.S. troops withdrew from Afghanistan, a Reaper was involved in a strike in Kabul that killed 10 civilians, including 7 children.
There appeared to be a threat. There was a white car that was traveling, looked like it was somebody who maybe belonged to ISIS, maybe had weapons, explosives in the trunk, so they fired. Turns out that it was a humanitarian worker actually working for a company that received US funding to help the Afghan people through humanitarian aid. And there were also civilians killed.
Air Force personnel we spoke to told us drone warfare keeps pilots safe by keeping them out of combat zones. But there are concerns about the decisions made by pilots operating the aircraft from hundreds of miles away, and some critics blame this distance for mistakes that have involved the Reaper in the past.
The emotional investment is not the same as if you are in a fixed-wing aircraft, meaning you are the pilot in a plane and looking down on that particular place. You might not have the cultural sensitivity, you might not be embedded with that community.
But the Air Force says processes intended to prevent mistakes do exist.
There's absolutely a process and really that soak and that study of an objective area to ensure that we're both going after the correct target and that we're both accounting for any collateral concerns that there may be with an objective area when there's the possibility of the employment of munitions on a specific target.
So what does it take to remotely fly the MQ-9 Reaper? And how are new pilots being trained to avoid harming innocent civilians? Military leaders began answering that question months after the incident in Kabul, when Secretary of Defense Lloyd Austin directed the Pentagon to come up with a plan addressing civilian casualties in drone warfare in January 2022. The Civilian Harm Mitigation and Response Action Plan was finalized in August 2022, and among other things, outlines where drone pilot training should be updated. Insider visited Cannon Air Force Base in Clovis, New Mexico, to see how pilots are being trained to fly this unmanned aircraft.
Phase 3 rolling.
The Air Force has been operating remotely piloted aircraft for a couple decades now, and a couple different versions.
Originally built for reconnaissance operations, the MQ-1 Predator was modified to fire missiles in 2001. And after September 11th, it was deployed to U.S. air bases near Afghanistan.
The MQ-9 Reaper was really the successor of the Predator with advanced capabilities, longer endurance, all around just a more capable aircraft that allows for that persistent ISR that the battlefield commanders so desperately need in order to increase their situational awareness and provide them with options for executing various mission sets.
These missions include gathering intelligence, surveillance, combat search and rescue, providing close air support, and precision strikes.
Welcome everybody to the ACE-39 brief today.
At 0530, the 12th Special Operations Squadron begins its training mission with a pre-flight briefing.
We have 4 Echo loads on there for 309 pounds weight and then 3,514 pounds of gas. No ER take. So the weight's going to put us at about 9,600 pounds, so we're going to be good to take off today, just no touch and goes yet.
Reaper missions are split into 2 elements, or teams. First, the launch and recovery element.
sunrise for the day is 6:22, so we could have birds and thermal crossover be a factor at takeoff time.
The pilot and sensor operator are responsible for working with the ground crew to get the Reaper safely in the air and headed toward the desired area.
We're just doing a launch directly to a departure. We'll go to high key for departure, and then we'll head out the range and get to 16,000 feet.
Once the craft is in the air, controls are handed over via satellite control to a second crew known as the Mission Control Element. This crew handles the specific aspects of a mission's objectives. When the mission is complete, the controls are handed back to the Launch and Recovery Element, which is then responsible for landing the drone safely.
All right, cool. Brief complete.
The MQ-9 Reaper is really known for its persistence and its ability to loiter for long periods of time.
An aircraft's loiter time is the amount of time it can stay in the air before needing to refuel. And the Reaper can stay in the air for about 20 hours at a time. The MQ-9's ability to complete such long missions comes down to design. It has a 66-foot wingspan, nearly twice the length of its 36-foot body. When empty, the Reaper weighs only 4,900 pounds, which, combined with its long wings, is key to helping it stay in the air longer. The standard payload weight on a Reaper mission is 3,750 pounds, but with an extended range modification, the aircraft can take off weighing up to 11,700 pounds. It's propelled by a single 900 shaft horsepower turboprop engine. The Reaper can be outfitted with up to 8 laser-guided missiles, including air-to-ground Hellfires. The practice weapons seen here are only used during training. With no pilot on board, all of the visuals are captured by a state-of-the-art sensor. MQ-9 Reapers are equipped with Raytheon's multispectral targeting systems, which allow long-range surveillance, target acquisition, and tracking. And while the sensors are high-tech, questions remain about whether they can provide imagery that's clear enough for the crews to rely on to make life or death decisions.
One of the issues that has been brought up about the Kabul drone strike is that there was fuzzy footage. I don't know exactly what part that played in killing 10 civilians. Technology will always improve, and I'm hoping that that technology will improve in service of not just lethality for the target, which of course is the US military's interest, but also minimizing harm to civilians.
So this is our ground control station. We have 2 cockpits within this box. So it's a portable box. We can load it up on whatever plane we need to load onto and get it anywhere in the world. So we maintain the agile capabilities required of us these days. You'll see cables coming out the back that run along the ground to these towers. These are our ground data terminals, so when we're flying the aircraft in line of sight, this is the actual tower that facilitates that data link in the line of sight.
The Reaper has a range of about 1,150 miles from the GCS, and with an extended range modification can reach 1,611 miles.
All right, so this is one of our cockpits. We've got one on this side and one on the other side to maximize space. So traditionally with all Air Force aircraft, the pilot's going to sit on the left side, and in our case, the sensor operator or our co-pilot sits on the right side. And we've got our heads-up display. It's off right now because we're not flying, but this is where you're actually going to see all your feedback for what the plane's doing. So all that the traditional physiological senses that you can't get in the MQ-9, you're going to see that here, and you have to learn how to interpret all that data with your eyes. So up here is our tracker map. So we can load all the maps of everywhere we're flying within the world. And then there's a lot of functionality on here. We can actually point and click at the any way where we want the plane to fly. We can actually put a loader right there. Click there and say, like, I want you to orbit within 5 miles of this point, and the plane's autopilot will go do that. We call it a pre-programmed mission. But we manage all the functionality of the map on top on that tracker. It's usually just a pilot and sensor flying the plane, but if we need to get any extra folks into the cockpit to execute our mission, we can sit them here at any of these stations.
The Air Force says that one benefit of having a ground control station is the ability to bring in assistance that they can't have on a traditional aviation mission.
With other planes, they can put a lot of people on the plane, but when the plane takes off, whoever's on there is on there.
If we're doing search and rescue, we could literally have a doctor come in and assess someone on the ground. We could have a survival expert in there if it's a combat search and rescue scenario.
After the pre-flight briefing, the crew and their instructors stepped to a large bay full of portable racks that resemble those inside the GCS.
So today we started off, we had to do a basic launch to hand over to the mission control element. Got our GCS prepared, got the aircraft turned on, checked to make sure all our data links were working, got the engine turned on, and then we took off, flew around the pattern once on our way out to the range to go do the handover.
I'm gonna throw the speed lever up. Taxi mode is on. Hades 3, clear for takeoff, runway 22, copy traffic.
Flaps are set, 10.4. I'm ready.
Cool, everyone ready? Yep. All right. Brakes are out, throttle full forward. Hades 3, rolling.
Rotate.
Rotate. Climbing on 1.
In undergraduate flying training, when we're learning how to fly, it's a very physiological force. You learn to feel what the plane's doing through the various sensories. Like you can smell stuff if something's not right. You can feel the G-force hitting your rear end if you're pulling G's. You can't do that in our plane because we're flying at 0 G's, we call it. So we learn how to feel the plane with our eyes. So we have everything in our heads-up display right there, and our tracker display, and get some engineering information down below. But you learn how to interpret all the data coming in through your HUD to feel what your plane's doing that you can't actually feel physiologically with the rest of your body.
Turbulence is a difficult one because all you can see is the plane rocking up and down in relation to the horizon of what you see in front of you on the camera. So you have to monitor the airspeed of the aircraft and what it actually looks like when it's moving.
After successfully getting the Reaper into the air, the launch and recovery element has time to perform a high-stakes training mission at the range.
We simulated having a Hellfire on the wing of the aircraft, and we found a target to engage with.
Building under your crosshairs. 1-3 Sierra Foxtrot Tango 131980. Your mark. Friendly's no factor. Egress back out the wheel for reattacks. Save and ready remarks restrictions.
Hades ready. Sorry, the fusing is strange with the Echo 11. That's what's going on here.
We got an opportunity to troubleshoot some stuff today. We had a missile that wasn't working properly that our pilot got a chance to experience, which was kind of something you don't get to do every day. It's not awesome, but it's good training for our launch and recovery pilots.
You're going to want to go to your status. So it just said failed verification. Then you'll go to station status.
We in this role, we have to be ready to go land a plane that's broken all sorts of different ways, and we have to be as best prepared as we can to go do that.
For target, it's the building under the crosshair. For aim point, top in the middle of the building works for me. We've got call in with rifle and time of flight. Plan here is to do it just from the wheel, and for shift, it's per the JTAC, and clearance on final, and egress will be to the wheel. All right, we're looking at 8 kilometers out right now. Time of flight is 32 seconds. All right, you ready?
Ready.
Here we go. Consent. Trigger.
Before firing the missile, the pilot must get consent.
There's crew coordination that occurs, and that there is that consent between the operators of the aircraft and the tactical controllers of the aircraft that what it is that we're actioning is in fact the appropriate and accurate objective.
Simulated splash.
You see a big effect. Terminate.
Master arm safe.
First and foremost, there's no warm body in the cockpit, right? So whenever we need to go into a high threat mission area, then we can send our plane in there without risk of losing our bodies, right? So we don't have any risk of losing a pilot, which that helps the decision makers a lot.
If you're a military commander, you don't want your men and women in harm's way. Drones can be very precise, very accurate. They can hit the target if you have the right information about that target, and sometimes they can minimize civilian harm.
But under international law and the Geneva Conventions, civilian casualties can be legal.
It has to be proportionate to the military target. You have to distinguish between civilians and combatants. And you can't just willy-nilly cause civilian harm. In addition, you don't have to recognize the civilian harm that you cause. You don't have to make an apology. You don't have to say, here's why that happened. These are things that the US military has learned over time that it needs to do. And that's what we're hoping to see in the future.
And though these things aren't required by international law, the Pentagon's 2022 Civilian Harm Mitigation and Response Action Plan includes official acknowledgement of harm, cases for civilian compensation, and preventative measures to stop future mistakes.
We see it as our moral imperative to make sure that we're providing the absolute highest standard of training to ensure that aircrew members who find themselves in situations of increased collateral are equipped with the tools and resources and training to ensure that we're mitigating any civilian casualty to the maximum extent possible.
And though removing drone pilots from conflict zones can limit physical harm to airmen, these pilots still deal with the impacts of war, like post-traumatic stress disorder.
They're not robots. It is a very emotional thing to be a pilot and get back from Afghanistan and go to dinner with your family and your kids, and they're deciding whether to shoot or not shoot. And that comes with an incredible burden, an incredible emotional burden.
And once we're done terminating, now you're going to reload the weapons for the handover.
With every military mission, there's a moral imperative to make sure that you're the best you can be at your job. We take pride in our ability to do the full mission over here as launch and recovery pilots, but also maintaining the proficiencies and the currencies for the weapons as well.
Despite its complicated past, the MQ-9 Reaper continues to be a key military asset.
Yeah, as we're moving away from some of our previous theaters of conflict, MQ-9 is still bringing that persistence to various theaters and various parts of the globe. It's also allowing us to contribute to the mission of integrated deterrence for any would-be adversaries or competitors in the various spaces around the world where there are competing and conflicting resources and priorities for objectives, security objectives.